Okay, class, picking up where we left off at, we had turned this 4.06 inches to feet. But remember, we want our final answer to be in miles to two decimal places. So now we have to change feet to miles. Now, there is 5,280 feet in 1 mile. So if we would get rid of these feet, it'd be 8,120 over 5,280, and that would be miles. Now we have to divide this out, and we would take our calculator, and we would have our 8,120 divided by 5,280. Now, again, we're going to round this to two decimal places. So again, I strongly suggest you write out this answer to three decimal places first, and then round to two decimal places. And since this third decimal place is 5 or more, our answer will be approximately 1.54 miles. And that will be our final answer. Okay, now we come to problem number 6. It says, if we looked at a satellite photo at the same scale, could we see any boats on the river? If a 50-foot boat were on the river, how big would it appear on the photo? Round to three decimal places. Do you think you'd be able to see it? Okay, now let's take a look here. If we take the 50-foot boat and we want to change that to the actual size, if we wanted to change that to the model size. So the actual size was 50 feet. So we'll put that over 1, and we'll multiply it by 1 inch with 2,000 feet. And then that would give us, the feet would simplify out, and we have 50 over 2,000, and that'll be inches. Now, when we put that in our calculator, which we could do here, so we would have 50 divided by 2,000. And then that would give us, as our final answer, it would give us 0.025 inches, rounded to three decimal places. Now, if you think about this, it says we looked at a satellite photo at the same scale. Could we see any boat on the river? So that means that 50-foot boat is only going to be 0.025 inches. The answer would be no. We would not be able to see that boat on a river because this is less than an inch. So the answer would be no. It says, do you think you would be able to see it? No, you would not, because this would be too small. Now we look here at number 7. It says, write a verbal description of the process of going from larger to smaller or smaller to larger. Okay, so first of all, here we would say larger to smaller, multiply by smaller value. If you look here, we went from the larger, which was feet, to the inches. Larger to smaller. Larger to smaller, we multiply by the smaller value because 1 over 2,000 is a smaller value. So now smaller to larger, we multiply by larger value, which we have here in number 5. You look here at number 5, we went from inches to miles. This is the smaller value to the larger value. You notice we multiply by the larger value here, which is 2,000 over 1, which is 2,000. Now, that took care of the first part of this exercise. Now we're going to move on to our next page. which would be on page 60. Okay, now on page 60, we're looking here at the bottom, and we're looking here at these different fractions that we would call a conversion factor. Now, one thing about a conversion factor that you need to know, you have two values that are equal to each other, like 3 feet and 1 yard and 3 feet. And we know except for 0, any number divided by itself is equal to 1, just like I'm showing you here. Any number divided by itself except for 0 equals 1. So 3 feet and 1 yard are the same value. So these are values divided by itself. So that's why these are equal to 1. And these are conversion factors. We use conversion factors where we're not actually changing the problem. We're using it in order to get a solution without actually changing the problem. So down here for problems 1 through 4, we want to go over the different conversion factors here. So since 1 meter is equal to 100 centimeters, we could rewrite that as one conversion factor as 1 meter over 100 centimeters. Or the other conversion factor would be 100 centimeters over 1 meter. Next, for number 2, we have 1 mile over 5,280 feet. And then the second conversion factor, we have 5,280 feet all over 1 mile. Third conversion factor, 12 inches over 1 foot. And then this conversion factor would be 1 foot over 12 inches. Next, we will have 1 inch over 2.54 centimeters. And then we will have 2.54 centimeters all over 1 inch. So this is just showing you that whenever you have values equal to each other, it doesn't matter how you set the fraction up, it's still a multiple of 1. Now, we need to go on to page 61. Now on page 61, we're going to start off with problem number 5. Now with problem number 5, it says earlier you wrote 2 conversion factors relating feet and inches. Below, multiply each of them by our measurement of 22 feet. So basically what they want us to do when we had the feet and inches, if you look back at problem number 3 on the previous page, it has 12 inches is equal to 1 foot. And we have the 2 conversion factors, 12 inches over a foot or 1 foot over 12 inches. So they want us to go over here and use both of those measurements. So we can have 12 inches over 1 foot and 1 foot over 12 inches. Now, they want us to multiply this. When we multiply this out, this will give us 264 inches because these feet would simplify out. And then it'll be over 1, so it'll just end up being 264 inches. Now we come here. Nothing will simplify out, and this would be 22 times 22 feet times 1 foot, which will give us 22 feet squared all over 12 inches. Now 22 and 12, you could simplify that, but we can put this in a calculator. We could take 22 divided by 12, and we could hit this button here, and then it would give us the fractional equivalent. So it'd be 11 square feet all over 6 inches. Now for number 6, it says for each multiplication above, what would be the units of the result? Now the first unit, we will see that it's inches. And then the second unit, we know it'll be feet squared over inches. Now, we go here to problem number 7. It says in one of the multiplications above, the units that we did not want, feet, divided out, and the units that we do want, inches, were left behind. That's great because we multiplied by a conversion factor. All we really did is multiply by 1, which didn't change the size of the measurement. It just changed the units that it measured in. And that, friends, is the point of dimensional analysis. Back to our calculation. How many inches is 22 feet? Now, we figured that out up here in problem number 5 when we were just left with inches. So we would just write it's 264 inches based upon what we had. But we can write it out here again, be 22 feet over 1 multiplied by 12 inches over 1 foot. Now remember, we're trying to get rid of these feet. So we got rid of the feet, and it ends up being 264 inches. Now, we move on to page 62. Now, it says, here's the great thing about the dimensional analysis. To do that conversion, you didn't have to figure out whether to multiply or divide to get from feet to inches. The units made that choice for you. And when conversions get more complicated, it can be really hard to just figure out what to do. That's when dimensional analysis is almost essential. Let's say we want to convert the 3 miles of driving distance from the map in the group activity to yards. Why would anyone want to do that? Because they can. Number 8, first use your conversion factor from question 2 to convert 3 miles to feet. Now, if we go back here, and this will be the last time I will flip back and forth because you could flip back and forth. They're talking about us using number 2, which is the 1 mile equals 5,280 feet. So, they want us to change these miles to feet. So it'd be 3 miles. We'll put that over 1. Now, remember, it's 5,280 feet is 1 mile. Since mile is in the numerator and we want to get rid of it, we'll put miles in the denominator. And then it'll be 5,280 feet in the numerator. The miles will simplify each other out. And then when we multiply this, it'll give us 15,840 feet. Now, for number 9. Now use another conversion factor to convert the answer from question 8 to yards. So we're going to take this 15,840 feet over 1, and we want to change feet to yards. So we will have 1 yard for 3 feet because we want to get rid of feet. So the feet will simplify out, and you have 15,840 over 3, and that's yards. And you put in your calculator to give you 5,280 yards. Now, number 10, it says, now here's a better idea. Convert 3 miles directly to yards by doing one 2-part calculation. Again, focus on eliminating the units you don't want by putting that unit on the opposite side of the fraction when you multiply by your conversion factors. This is why we had you write conversion factors 2 ways, so you could get accustomed to the idea that you get to pick which unit goes on top and which goes on the bottom. Okay, so we will have 3 miles over 1, and we will have 5,280 feet all over 1 mile because we want to get rid of the miles. Now, we also would do 1 yard over 3 feet because we want our final answer to be in yards. So the miles will simplify out, the feet will simplify out, and you will have 15,840 over 3 yards. And that would give us 5,280 yards. Now we come here to number 11. It says, we've been focusing on units of length, but dimensional analysis can be used to convert anything that can be measured in more than 1 unit. There's a list of conversion factors on page 64. Use factors in that table to find how many cups are in a 2-liter bottle of Dr. Pepper, round to 2 decimal places. So we would take 2 liters over 1 times. be 1.06 quarts over 1 liter times 2 pints is 1 quart, and 2 cups is 1 pint. Now, the liters will simplify out, the quarts will simplify out, and the pints will simplify out. Now, when you multiply everything on the numerator, it'll give you 8.48 all over 1, and that's cups. So it'll be 8.48 cups. Now, I do want to show you, as it said on page 64, what you have here. You have all of these conversion factors on page 64, and you would just look through and pick out the ones that you need, just like I did in problem number 11. Now, we're going to move on to problem 12. Now, with problem 12, it says sometimes scale is described in terms of percentage. For example, for the film of the Academy Award winning film Titanic, a model of the stern of the ship was created at 12.5% of the actual size. A section of rail on the stern of the real Titanic was 24 feet long. How long was the corresponding section on the model used for the movie? Okay, so we were at 24 feet, and then it tells us the scale is 12.5% of what the actual size was. This is the actual size. We could change this to a decimal, so it'd be 0.125, and that would give us 3 feet. Now we go on to problem 13. If an I-beam on the model spanned 30 feet of deck space, how big was the corresponding I-beam on the actual ship? So now, the I-beam was 30 feet. And then it says how big was the corresponding I-beam on the actual ship. So we know 12.5% of the actual ship. Okay, so 12.5% will be 0.125 times x equals 30 feet. So 0.125x is equal to 30 feet. We divide each side by 0.125. And x will equal to 240 feet. And that would be your answer here. Now, for number 14. Now let's turn this into a problem we already know how to solve. Given that the model size is 12.5% of the real ship size, write a reduced fraction that describes the scale in fractional form. Now, 12.5% is the same thing as saying 0.125. We've established that earlier. So we could change that to a fraction. That'll give us 125 over 1,000. Now we could use our calculator, and we could type this in. We'll take 125 divided by 1,000. And then we could push this button here, and it'll automatically give us the fraction, which would be 1/8. So the scale model is 1/8, or you could write it as 128. So that would be your final answer for problem 14. Okay, now problem 15. It says, quick quiz. Is it illegal to make color copies of United States currency? Most people think it is, but that's not entirely true. According to the Counterfeit Detection Act of 1992, you can make color copies as long as they're less than 75% or more than 150% of the original size. Write a reduced fraction like you did in question 14 to describe each of those scales in fractional form. Okay, so basically, they said that it has to be less than 75%. So whatever value must be less than 75%. And the other value must be greater than 150%. Now, they said they want us to write it as a reduced fraction. So it'd be x is less than 75 over 100. Now 75 over 100, we know 25 goes into both of these, so it'd be 3/4. So x must be less than 3/4, the size of the bill. And then this bill must be more than 100%, so that's greater than 150%. So x would be greater than, this would be 150 over 100. And if you put this in your calculator, it'll end up being 3/2. So these are the two scales that you would be dealing with. One scale will have to be less than 3/4, and one scale will have to be greater than 3/2. Now, when we go to our last problem, which is on page 64, and it's problem 16. Now with problem 16, it says an actual bill measures 2.61 inches by 6.14 inches. Are we in trouble with the feds for the reproduction below? Describe how you decided. Bonus points if you use the scale fractions you wrote in question 15. Okay, listen. Because I did not have a ruler here, I'm just going to write down what this measurement is. It was supposed to be, so now I can actually take this ruler here and measure this money. Okay, it looks as though this is, let's go down here to the side. We will have down the side, it is, I have to slide this over a little bit. Okay, there are 16 tick marks to go from 1 inch to the next. So this is a little over, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, it's about 10. So it's 1 and 10/16. 1 and 10/16 inch. And this here would be closer to, let's see, 3. It'll be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So 3 and 13/16. Okay. Now that we have these actual values, we can rewrite these as decimals. So let's put this in a calculator. We can round to 2 decimal places. So we will have, let's do 10/16. Say 0. So it'd be 1.625 inches. And then here we would do 13. 13 divided by 16. So this would end up giving us 3.8125 inches. All right, so now we have the measurements of this this bill here. So what we need to do, we need to compare this to the 2.61 and the 6.14. So we could go off to the side and we could see to take 2.61 and multiply by the 3/4. Remember the 3/4 was the 75%. So that is approximately 1.96. So this side here will have to be less than 1.96. And then we would take this side here, which we would take 6.14 and multiply by 3/4, and it'll give us 4.60. And both of these are inches. So we just proved that this bill is okay because these sides here are less than 75%. This side is less than a 1.96, and this side is less than a 4.60. So this is how we actually proved it. So now, so in description, we would say our measurement of 1.625 inches by 3.8125 inches is less than 75% of 1.96 inches. Well, actually, it's of the 2.61 inches by the 6.14 inches, which is the size of the original bill. So this is less than 75% of the original bill. So that proves that this is a good bill for us to copy. And we're done. Also, if you have any other questions, please email me, or you can wait till our big blue button session and ask any questions that you need. Have a nice day.